So, hello guys, welcome to our next video in the playlist Google Earth Engine for the beginners. So, this is kind of intermediate level video where we are going for the clustering of the image. We are going for the creation of a super pixels based on their relative connectedness for each pixels. So, we are going to use the KMeans as well as the SNIC tool or the algorithms for creating the clustering over an image. So let's start by importing our Sentinel-2 dataset. I'm searching Sentinel. I'm importing level 2A multispectral instrument data collection and renaming it as S2. And I'm also have to filter it down to an image. So I'm creating a variable called image. So if we just come to the docs and search clusters, so you'll see we have the algorithms for the segmentation of an image, ee.algorithms dot image of segmentation, where we have three methods for computing the clusters over an image. So we are going to try first the SNIC, the simple non-iterative clustering type. So as you can see, it need the input, the image for clustering. So we have to create an image from the Sentinel to image collection for our boundary and cloud cover percentages, and we need to also give some of the uh, arguments such as the size, compactness, connectivity, neighborhood size, and seats. So if you can see, they're all optionals. They are in italics. So if you want, you can specify them, or else it will take by default. Like the default is 5 for the size of the super pixel seed locations in pixels. It means there will be minimum of a 5 pixel distance between the each of the seed locations where they are going for the clusters, and the compactness, the default value will be 1, so you can set it to 0 for spatial distance weighting, and to disable the spatial distance weighting. And in terms of connectivity, how the algorithm should look for the connectivity in the eightfold directions or the fourfold directions. So usually we go for the four fold directions for connectivity. And neighborhood size, we can also give default to 2 into size of the pixel in order to avoid the boundary artifacts. And we should also specify the seed image if we have already created the seeds, or else it will take the default as null. So let's start. It will also return an image. So let's start by creating a variable called image. From the Sentinel-2 collection, I'm applying the filter bounds for region of interest. So I should define my region of interest now. So I'm going to a region in the Kodagu, that is Madikeri. So zoom into Madikeri, and I'm choosing the draw rectangle tool from the geometry tools, and I'm defining my region of interest to be this much. Okay, so let's rename it as ROI. Now I have filtered my Sentinel to image collection for my boundary, and I should also filter it to date. Let's say I'm filtering it to the latest collection of 2024 from January 1 to 2024 12. Sorry, it should be string now. So 2024 12 31. I'm filtering it to the latest, to the yesterday. So I should also take the cloud cover. So I'm using filter. So we can also filter the cloud cover with the help of filter metadata function. But if you can see here, this function is currently deprecated. It means it's saying instead of using this, use the filter with e dot equal to greater than functions instead of using the filter metadata function. So I would recommend that one only. So if you can run this filter metadata also, it will work, but only thing is that it will lag. So I'm going for the suggested ones. E dot filter dot less than, I should filter the cloudy pixel percentage. I should give the argument as a cloudy pixel percentage. Okay, and it should be less than, say, 1%. Okay, now my filter is ready. Let me print this in order to know how many images are available uh, for this filter. So let's give it a run. You can always choose control plus enter in order to run the script. So we have four elements less than 1% for this data range and for our building boundaries. So I think that's enough. So let's take a composite of it, and we are creating a median composite for the four image. Okay, and I am also want to clip for my region of interest using the function dot clip to ROI. So let's add it to the map in a true color composite map the dad layer image, and I should define my visualization parameters. Let's say the minimum is 0 and the maximum reflectance is 3000. So we have not yet multiplied by scale value, and we are displaying the multiple bands, so we should specify uh, the bands which we need to visualize in a RGB channel. So we are going for true color composite, so I'm using red, green and blue for the red, green and blue channel only, RGB channel, and let's name it as true color composite. Let's give it a run. It's loading now. Yeah, so here if you can see our image is loaded. We have the true color composite of the image for our data of interest and region. So let's do the clustering for this image. Let's see how does it look like. So I'm creating a variable called SNIC cluster. So we should take the input as an image, and okay, we can do like that, or we can use e dot algorithms dot sentinel no, image dot segmentation. Yeah, from this we are using SNIC. So the image, we need to create our image only for the cluster, and let's say the size. So let's go to our dictionary again, documentary on the function e.algorithms for the segmentation of an image using the simple non-iterative clustering method. So here if you can see the size, it's a super pixel seed location spacing in terms of pixel. So if the seed image is provided, then no grid is produced. So we need size, let's say 10, and let's say compactness is 0, and connectivity is for by default it will be in 8 fold connectivity. So I'm doing it for 4 field connectivity because sometimes it may give some error, and the neighborhood size let's say 10, and seeds should be 5. So just done this. So now we have to add it to the map. It's an IC, and we should also print them in order to know what are the changes we have. Okay, we have an error. Yeah, we should give the connectivity in terms of 4 or 8, not in terms of true or false. So that was the error we are encountering. So if you can just expand the band, here you'll see we have uh, one more band named as clusters in terms of ID. So our cluster layer is loading still. So yes guys, just comment out these arguments in order to have by default values. So we should have a more kind of specifications in order to go for this argument. So I have just left it for default. So here you can see we have the clusters now. So let's inspect. So just come to band 1 and select the cluster, and expand it. Click on the apply. So we have too many clusters now. So if you can just click on this, you will get the clusters for different kind of clustering of an image. So these are just connected pixels which have uh, more kind